So from here on out, anytime that you have a sentence with is and a percentage and the word of, you're automatically thinking about that proportion that you can set up. Is over of, percent over 100. Now again, the problem's like this one right here, where 84 is 16%. We always said that the is number was either before or after it. Well, the percent is after it, but if it's the percent, it's got to be the percent. Okay? So just down here, we have is 20% of 110.
Oh.
Is that you?
Oh.
So you,
Yeah, I'm using the force to like flip the lights on.
so any of those that we need to go through? Anybody need any of those to go over? Basically what we just did in our 4 problems. You'll get more practice with that today and tomorrow. Okay? And again, the only reason that we keep hammering this, it's a really important concept. All right? From there, then we talk about discounts. What's a discount?
A percentage taken off.
Okay. Is a discount good for us?
Yes.
It depends how much of a discount it is.
So if I just give you a discount or I say you have to pay full price, even if it's a little discount, you're going to pick the full price sometimes? No, right? So discounts are good. So we're going to look at how to figure out a discount. Okay? So we know that it's good for us. It's going to be amount that we're going to take off. The most important part of this is you need to answer the question for what is being asked. Okay? Does that make sense? Because they could say, what is the discount and what is the discounted price? You understand what the difference is there? What's the discount means what?
Like the amount taken off of it.
Right. And the discounted price would be
The price after.
the new price, right? What we're actually going to pay. So that's really, really important concept. All right? So in a sense, we can do the same principle and use is over of again. Because is over of, the other way that we said is over of was what?
Part.
The part over the whole, right? So basically a discount would be the part, right? The whole would be my original problem or whatever I was figuring out as the original price. Make sense? So I can do this. Now the tricky part is this. When you do the is over of portion and they give you a portion of it, you have to make sure that you understand what you are putting into the problem. So again, am I trying to find the discount? Am I trying to find the discounted price? You kind of got to do the percentage one of 2 different ways. So realistically, what I'm trying to get to for you to think about here is when I set up the problem, I'm going to do it the same way every single time. I'm going to figure out the amount of discount using the percent. Some of you might want to just go by what the actual problem says and adjust what your percent is. To me, that gets confusing because then I'm really having to stop and think about what I'm actually trying to figure out. That makes sense what I'm saying there? Kind of? Well, like, here's a problem. Everybody read this problem right up here. The regular price of a ring is $495. It is on sale at a 20% discount. What is the sale price of the ring? So if I use all of that information that's given to me right there, and I put it into that formula right there, what do I find? Do I find the discounted price, or do I find the discount? Read what it says. If I just use that information right there, I'm finding the discount. Because it says it's a 20% discount. Okay, so what would I have to do at the end with the answer that I get out of that proportion? I'd have to subtract it from the amount that is the regular price, right? So, if I did the problem as they said right there, I'm going to write what is 495 in my proportion. The of or the whole, right? So I know 495 is down in the bottom, and then I would have 20 because it's a percent over 100. Everybody agree? But this is when I want to find the discount. So in this particular problem, though, it says, what is the sale price of the ring or the discounted price? What am I going to pay for the ring now? So if you wanted to do that without doing the last step, which is subtracting, then I would switch, and you can do it this way too. You could still use 495. I'm still trying to find X, which is my price. I'm still going to have 100 down here, but instead of using 20, I'm going to use what in the problem? 80%. Because then this says it's 20% off, so this is the amount of discount. This is 80%, which means I'm going to pay 80%, which is my discounted price. You see the difference between the two?
Oh, yeah.
So again, you can totally use both of those, and then you don't ever have to really subtract anything. Or you can just use one of them, and then you just have to understand what you're trying to find, and you might have to subtract. Does that make sense what I'm saying there now?
Yeah.
So in this one right up here, if I use this formula to find that problem's answer, I would have to do one more step in this one, right? Because then I would have to take my answer and I'd have to what? Subtract it from 495, right? And that right there would be the discounted price. If I wanted to just do the discounted price, then I could just use this bottom one. So it's totally up to you what you want to use. I'm not trying to tell you which way or how to do it. It's just, does your melon see the difference between the two?
Yeah.
Okay?
I don't understand.
So after you get your answer from like subtracting, would that be the number that would go over your 495?
Right. Realistically, when I did this problem right here, this answer right here would be the same thing as if I did this problem to match that answer. This answer right here and this answer right here won't be the same number. They'll get you to the same number, but they won't be exactly the same number. Does that make sense what I'm saying? Because if you, did somebody do this problem?
Yeah, 99.
$99? Okay. Did somebody do this problem down here?
Yeah, it's 396.
$396?
Yep.
Okay, so this answer right here is the answer to the problem that was asked. This answer right here, I would have to do this, and I should come up with that answer right there.
I thought you were saying like the answer that you get from after you subtract is going to be.
No, it'll never go back into, well, yeah, it will go back into this one. Right. But does that make sense now, what I'm trying to show you there? Okay, so again, I'm not trying to show you or tell you which way to do it. I'm just telling you that you just have to realize there's two different ways of finding the answer. Okay, so let's try it again. All right, so let's move this over here so we don't really need this today, but somebody might be gone in the other class. All right, so we're looking at the DVD player. Okay, this one right here. Find the discount for a $268 DVD player that is on sale for 20% off. So again, as you're looking at this problem, answer me this question without telling me the answer. Is this answer that you're going to find the same thing that we found in the first problem? No. Right? In the first problem, they asked us to find the what? The discounted price. In this one, they asked me to find what?
The discount.
The amount of discount. They're asking you, how much did you get off? They're not asking you what you paid. Right? The amount I got off isn't what I paid. Agreed? Okay? So, again, now what are you going to do? That's the question, right? All right? So, first proportion or second proportion? First, right? Remember, the first is by just using the percent that they give me. So I'm going to do 20 over 100. But now, what is the whole?
268.
Right? The whole, again, is what the original price of whatever we're talking about is. And then I just go back and now I'm ready to do my problem, right? So, 268 times 20 divided by 100 is?
53.6.
$52.60.
Okay, so now, obviously, in these kind of problems right here, do they have to tell you what to round to? No, because you should always know that you're going to do dollars and cents. And unless you know something that I don't know, cents means there's 2 decimal places. Put your hand down.
There
Put your
is
hand
a
down.
small-
Put your hand down. Okay? So, again, what does $53.60 mean? That's the amount of discount we're taking off. So, we can take it one step further now and say, how much did we pay for the DVD player? And what would we do? Take 268 minus the 5360, and we would say what? 200 what?
$214.
So, again, $214.40. So, this is my discount. This is my discounted price. What else can we call this? Okay, the total maybe. What else? If it's on discount, it's also a what? What's another word for it? A sale. So if they call it the sale price, that's the same thing. Make sense? Okay. We need to do another one. Yes? All right. So we're back here, and we're going to look at the jacket. So a jacket normally sells for $180 and is on sale at a 35% discount. What is the sale price for the jacket? So is this answer the same one that we just did in blue? No. It would have been the end answer that we got. So you have 2 options for this one. You can do it the top way, but then I have to subtract, or you can do it the bottom way. Essentially, you're subtracting something all the time, though, right? Because if I do the second one, I am subtracting. I'm taking the percent they gave me and subtracting it from 100. Right? So you got to do subtraction sometime, but just when. So this is what I'm telling you that in normal, or to me, I would try to be as consistent as possible, meaning I'm going to pick one of those 2 and stick with it. Instead of trying to kind of go back and forth between, depending on what they say in the problem.
Oh, how do you bottom it?
You're going to try to do the bottom one? Okay. So, what is the sale price? 35. 180.
Got one.
Right? $117?
Yep.
No. What? I'm simply wrong here.
Everybody agree?
Yep.
So again, make sure you answer the question. This one says, what is the sale price? My sale price is $117 because I got $63 off. Okay. Now, why would a company run a discount or a sale? If they're closing, great time. What else?
Too much.
If I had too much of something, right? What else?
They just opened.
Maybe if they just open, probably not though. Holidays maybe, okay. Maybe I have a store like, let's say Walmart, that sells year-round stuff, and we're going from winter to spring, right? We might have a sale on our winter stuff because we had too much left over. We don't want to carry that anymore. Okay, so think about that. All right, any questions here? The next part in this section, they introduce a formula. And the formula we're going to talk about is simple interest. Have anybody ever heard of simple interest?
Describe it to me.
Where would you get simple interest from? When you put the money into the bank, exactly right. You're trying, okay, maybe some stocks. Stocks might not necessarily be simple interest, but more of a savings account. Anybody have a savings account? A checking account? Okay? Some of those things, all right? So a simple interest, there's a formula. And this is a really popular formula too. If you take my other class, business math, as a junior or senior, you would do this a lot. So my formula is capital I equals capital P, little r, little t. All right, any idea what any of those letters mean? What does I mean?
Interest.
Yeah, I is interest. So in this case right here, is interest, did I spell that right?
Yes.
Is interest good for us?
Yes.
Is there bad interest?
Yes.
When's bad interest? When you take out a loan, exactly right. If I have a mortgage on my house, okay?
Does that mean like price range?
No.
Ah.
Okay? So today we're talking about good interest. So this is a positive for us. Anybody have any idea what P stands for in one of these problems? Not price. Price is kind of a good quote.
Profit?
Okay? You're just throwing P words out there now. But that's okay. Pie. Price isn't bad, but they actually call this the principal. And I think it's like, yeah. Okay. What's the principal mean? It's a price. Say what you're gonna say. Good thinking, okay. He's the guy that makes the rules, right? But not in this case. Anybody else want to guess? The principal is the starting amount. So the principal would be how much you started your savings account with. How much you took to the bank to say, well, how much money am I going to make? All right? R, what do you think R means?
Rate?
Perfect. R is a rate. So if it's a rate, what is it?
How long, like how fast?
Okay, I understand what you're saying there. That's the rates that we've talked about before. Different kind of rate though. Anytime that you talk about rates and money, you should think that the rate is going to be what kind of a number?
Big number.
This is going to be a percent. Okay? How do I take a percent and turn it into a decimal? To the left. Okay? That's why this is in this. And what's T? Time. When you do I equals PRT, time is in years. So, when we have letters that are right next to each other, what's it mean in math? That we're going to multiply them together, right? So we're going to take the P times the R times the T, and that's going to tell us how much we make in the I, or the interest, through that period of time. Okay? So you're taking money to the bank, and you're going to find out how much money you're going to make. So, here we go. Read the problem right up here. If you invest $2,000 at a rate of 4.5%, how long will it take you to earn $495 in interest? Okay? Everybody read it? Everybody understand it? Now, try to put those numbers in the right spot in the formula. Okay? So, we are going to use our formula of I equals PRT. Do I have the interest given to me?
Yes.
Yes. So this is a little different, which is fine. We're going to start out with that amount. Do I know how much money I put into the bank?
Yes,
How much?
2,000.
2,000. Times, right? Because PRT means P times R times T. Do I know my rate?
Yes.
Yes. So every time they give me a percentage, I'm automatically going to turn it into a decimal. So what's my decimal?
Well, 0.4, no, 0.45,
0.045. Because again, it was 4.5%, right? And I'm always going to take my percent and move it into a decimal. That's where I get that right there. So take every single percentage and turn it into a decimal. How much time? We don't know. So we put t into the problem because we need a variable, right? We always need a variable to find. So if I go back to thinking about my order of operations, and I think about how to solve to get t all by itself, what would I do to this problem?
Divide.
What should I do first, though? I'm still going to multiply by these two things first, and then divide, right? So, anybody punch in their calculator 2,000 times 0.045? 90? So we have 495 equals 90t. Now how do I get t all by itself?
Divide by
Now, like Addie said, we're going to divide. But again, I need to multiply first because of the order of operations, right? PEMDAS. We're going to multiply here before we divide. So my 90s cancel out. T is equal to what? 5.5 what?
Years.
Years. So let's think about this. If you guys had $2,000, how many of you have $2,000? Okay. You put it in the bank where they're giving you 4.5%, and you don't touch that money for 5.5 years, you make almost $500 just for it sitting there.
I wonder how much I made for just putting $20 in the bank since I was like 3 years old.
Well, you could figure it out if you knew the percentage.
I was 3 years old and I don't remember.
Yes, sir.
What if the interest is something one year, but it changes the next?
So, great question. Everybody hear his question? That's a great question. Normally, when you do, you would know what kind of account you're putting your money into. So some accounts, it's a set rate all the time, and you're locked into there for a certain number of times. Sometimes it might change daily. And so that would be what they call, it's still simple interest, but it's compound interest. And so it's building off of or going up and down. So you would know that. And then it would adjust. Okay? But that's a great question. All right? So let's try another one. Does that make sense though, what we did there? All right? So the biggest thing here is you got to know where it's going to fit into the formula, right? So the next one, if we do this one right here, okay? Say they invest $500 at 5.5% interest. In 2 years, how much interest will she earn? Basically exactly the same kind of problem, but what? Now what are we trying to find? So we're trying to find capital I, right? Last problem, we were trying to find T. So it doesn't matter what we're trying to find, we're going to use the exact same formula. We're just going to adjust the problem, right? So, what are we going to write for our formula? So again, in this case right here, is this good interest or bad interest?
Good.
This is still good, right? Because she's investing. If I invest or put money into the bank, that's good interest for us, okay? So what's my formula gonna be? I equals
$500.
500
$0.55.
0.055, remember to move it 2 places to the left, times 2. Now what do I do to find my answer? Just multiply them all together, right? So what's 1,000 times 0.055? One, two, three. Made $55, right? Shouldn't even have to use a calculator for that one. Right? This times this is 1,000. If I take 1,000 times anything, there's 3 zeros, so I just move it 3 places to the right. Okay. Make sense though? Same exact formula, just 2 different kinds of problems, or 2 different kinds of answers. Here I'm trying to find time, here I'm trying to find the interest. Okay? Next one. We're going right underneath there. Ricardo borrows $250 at 9% interest. In 6 months, how much interest will he pay? So is this good interest or bad interest?
Bad.
This is bad interest. What do you notice about bad interest compared to good interest?
6 months to a year.
Okay. What else? Even more important between the blue one and the one below it.
Interest rate's higher.
Yeah. Look what happens when you borrow money from the bank compared to when you give them money to put in the bank. They almost double your rate. So guess what? How do banks make money? They want you to borrow money from them. They want you to take out a loan. Now, am I going to do anything different here
Yes.
in that calculation? No, right? I'm still going to find out the interest the exact same way. I just have to know in the back of my mind, in this problem right here, when I do the math, I'm still going to do the math the exact same way. So set up your problem how you think you would set up the problem. So, I equals, how much did I borrow? What is my rate? 0.09, and what is time?
6.
Okay, so remember, it's always in years, but they said 6 months, so that is 0.5 years. So essentially, like Miley said, we're really not doing the problem any different. You just got to make sure that it's in years and that you know what you're going to get. So, what is I? $11.25. All right, so here's the question. How much would I owe the bank?
22.50.
No, $135.
Okay, for per year, I understand. But if I told you that I wanted to pay back my loan after that 6 months, that's how much interest they're charging me. But what do I owe the bank?
$135.
Don't forget the amount that I borrowed, too. So I owe this because this is my kind of payment to the bank for borrowing that money. But if I borrow that money, I also have to pay back that original amount. So I would add these 2 numbers together, and as Caleb said, we would have $261.25. This is what I would have to pay back to the bank to get rid of my loan altogether. So I just want you to see, we use the formula the exact same way, but you got to realize, is it good interest? Is it interest for us that we're making? Or is it quote unquote bad interest that we have to pay on, but then we also have to pay what we borrow from them too? That makes sense? The difference? Okay. Next one's pretty much the same. Doesn't look like they ever asked, or at least in the example ones, what the percent would be. But again, they might do that, and then our rate would just be R in the problem. Okay, and then we would have the P and the T and the I. We would multiply the P and the T together, and then take the I minus, or sorry, divided by whatever we have for the P times the T. Okay? Want to do another one of these? Okay, so look up here. The last one or the one above it? I don't care which one. One above it? So what is the interest on $8,000 that is invested at 6% for 3.5 years? So we're doing that one right there. Try to set it up on your paper.
That's a lot of money.
That's a lot of money. This one, good or bad interest?
Good.
This is good, right? Because we're investing money, right? So again, it says what interest, so I know that I'm trying to find I. The other thing that I'm going to tell you right now, notice, so this is the formula that you should have done, right? I'm going to tell you right now, if you go to a bank and they say they're going to give you 6% interest, take all your money and put it in there. I'm not kidding you. Because right now, the interest rate for, like, my checking account is 0.4%. Look how much difference that is compared to 6%. Right? So if they tell you you're going to get anything over 5%, take all your money and put it in there right now. If they get to 10%, you better call me. Because I want to put my money in there too. Okay? But I'm telling you right now, interest rates, they are not at 1 right now for your savings accounts. 1%. They're not.
What if you have 100%?
Hey, remember your promise to us?
Yes, I'm like, what would 100% do? Like double like it? Like,
Yeah, every single time that, every cycle. That ain't never gonna happen.
So 16,000.
So you will get the assignment tomorrow in class, okay?